Problem 18. An electron is accelerated from rest by a potential difference of 380 volt. It then enters a uniform magnetic field of magnitude 200 millitesla with its velocity perpendicular to the field. Calculate the speed of the electron and the radius of its path in the magnetic field. In this question, we have two sub-questions. So in the first part, we are going to find the speed of the electron, and in the second part of the question, we are going to calculate the radius of its path. So first of all, let's write the given first. So what are the informations given here? So the information given here is we are just going to take an electron. So initially the electron is at rest, and then by giving the potential difference of 380 volt, we are going to accelerate the electron from rest. So what is the potential? The potential value V is equal to 380 volt. This is the potential. And then after you give this potential, the electron is accelerated, and this electron is entering the uniform magnetic field, and the magnetic field value is 200 millitesla. So that means the B value. So 200 millitesla in terms of Tesla, it is 200 multiply 10 power minus 3 Tesla. And they clearly mention the speed is exactly perpendicular to the field. So what we studied in the theory, so if the speed is perpendicular to the field, then its magnetic force will be greater, right? So they clearly mention that means the angle here is exactly 90 degree. So by using this information, we are going to find first the speed of the electron, and then second one, we are going to find the radius. But here, for calculating the speed, we need the mass of the electron. So the mass of the electron is a constant value. So the mass of the electron, ME, which is 9.11 10 power minus 31 kilogram, we are going to take. And also we need the charge of the electron, because here electron takes the negative value of the charge. Let's we take the magnitude. So what is the value of the charge of the electron, which is 1.6 multiply 10 power minus 19 coulomb. So we need these two constant value for finding the answer for the speed of the electron. So here the most important thing, the electron, when the electron starts from rest, its potential energy is converted to kinetic energy. As we already know, if you give the external potential to the electron, what will happen? The electron will be accelerated. So by that, the electron will gain a kinetic energy. So electron volt given to the electron, that means the charge, we are just providing the voltage to the charge. So once you just give the accelerating potential, accelerating voltage to the electron, what will happen? It will have the kinetic energy. So the kinetic energy formula is half mv square. So don't get confused about this v and that v. Actually here the caps v stands for the potential, the voltage. We are just going to give this potential to the electron to accelerate, and here the small v stands for the speed. So now here we are going to use this formula. Now I'm going to rearrange this equation in terms of speed. So if you rearrange this equation in terms of speed, what you will get? V square, which is equal to 2 multiplied by the charge of the electron multiplied by the external potential, that means the potential difference, divided by the mass of the electron. So here m stands for the mass of the electron. So I have to write me. So me means the electron mass. So now I'm going to take the square root on both sides for calculating the speed. So if you take the square root on left hand side, you'll get v, small v, and in the right hand side, everything will come inside the square root. So 2 multiplied by the charge of the electron multiplied by the external potential divided by the mass of that electron. Now I'm going to substitute the values in this equation. We have all the values. So first I'm going to substitute the value of the charge. So 2 multiplied by, it's a magnitude of the charge 1.6 multiply 10 power minus 19, and the external voltage we are just giving is 380 volt. So 380 divided by the mass of the electron is 9.11 multiplied 10 power minus 31 kilogram. So now I'm going to calculate. Let's see what is the answer. So here 2 multiply 1.6 10 power minus 19 multiply 380 divided by 9.11 10 power minus 31. So here I got the answer as 11.55 multiply 10 power 6, and the unit for the speed is meter per second. So this is the answer for the first question. So let's rewrite. This is the answer for the first question. So that means we completed the part A. Now in the part B, we are going to find the radius of its path. So what is the radius? When the electrons enter the magnetic field, what will happen? It will undergo the circular trajectory. So it will be moving in the circular path. So when it is moving in the circular path, it will have the radius. So that value, that means the radius value, we are going to find in the part B question. And in the theory, we already studied the rule for finding the value of this radius. So B formula, the radius takes the formula R equal to mass of the electron multiplied by the speed of the electron divided by the charge value of the electron multiplied by the magnetic field. So this is the rule we studied in the theory. Now I'm going to substitute the value here. So what is the value of the mass of the electron, which is 9.11 multiplied 10 power minus 31 multiplied by the speed value. I'm going to take the answer of the first part. I'm going to substitute the value here. So here the speed is 11.55 multiplied 10 power 6 divided by the magnitude of the charge of the electron is 1.6 multiplied 10 power minus 19 multiplied by the magnetic field. Here they give the value of 200 millitesla. So 200 multiplied 10 power minus 3. So let's see what is the answer for this radius. 9.11 10 power minus 31 multiply with 11.55 10 power 6 divided by 1.6 10 power minus 19 multiply 200 10 power minus 3. And here I got the answer as 3.288 multiply 10 power minus 4, and the unit for the radius is meter. So this is the answer for the second question. Clear? That's it. Thank you.